Okay, let's look at the practice exam 3, problem number 10. All right, so we want to find the area of the region bounded by enclosed by these two graphs. All right, so first we need to know what they look like. So let's find the intersection points of these two graphs. All right, so g of x is x plus 2. Right? And set that equal to f of x, which is negative x squared plus 4x plus 2. Right? Alright, so I'm going to try to put everyone on the left hand side. So I'm going to go ahead and so we're going to have to. Alright, so add x squared so that I can move this guy over to the other side. Then subtract 4x, right, so that I can move 4x to the other side. And then, oh, actually, I'm going to go ahead and cancel 2 on both sides. Right, so what you have is you're going to have x squared on the left because you're adding x squared. Right, then subtracting 4x, but you have x already here, so it's going to be negative 3x. Right, so that's everyone, and then nobody is on the right hand side, so it's equal to 0. Right, then we can factor it out. So this is an easy one, so we can pull out the x. So you have x minus 3 is equal to 0. Right, so therefore we know that x is equal to 0 and 3. Right, so let's sketch the ballpark picture. Right, so it's going to be, so I'm going to draw x-axis here. All right, so that's the x-axis, and here is the y-axis. All right, it's not very straight, but that's all right. All right, here is y. All right, then let's see. So let's draw this guy. So g of x is a straight line. Slope is 1, and the y-intercept is positive 2. So you can see that, let's say I'm going to put the positive 2 right here, and the slope is 1. So it's going to probably look somewhat like, whoops, right, somewhat like this, right? Just a straight line, right? So that's our g of x. I'm going to just put g there, all right? Then the f of x is a parabola because it's a quadratic function, and the leading term is leading coefficient is negative, so which means that it's facing down, right? So I'll probably put the 3, so 1, 2, 3, right? Because 0 right here, so he has to go through here, and 3 is another intersection point here, right? So it's a parabola facing down and going through those 2 points. So I'm just gonna draw a ballpark picture. So it's gonna look kind of like this, right? Doesn't have to be precise, but looks like the enclosed region is bounded below by this straight line, which is G, and bounded above by f of x. So f. Right, so the region that we are looking at is this guy right here. All right, let's find that area. So that I'm going to call that area A. Right, so area A, right, can be found. Right, so that's going to be an integral. Right, and start from 0, ends at 3. So from 0 to 3. Right, the top curve is the parabola, so I'm going to put the top guy. So it's negative x squared plus 4x plus 2, right? Then minus, you subtract the straight line, which is x plus 2, right? Then dx, right? And to clean it up, so you have a 2 here, minus 2, cancel out. Then we can clean it up a little bit, so it's an integral from 0 to 3, right? So you have a negative x squared, so negative x squared, right? Combining 4x here, and you have a minus x, so you're going to have plus 3x, right? Then dx, right? Let's take the antiderivative. All right, antiderivative of negative x squared would be negative x cubed over 3, right? Then antiderivative of 3x would be, 3 is a constant, so x squared over 2, right? Then you're going from 0 to 3, right? So we plug in 3, so that's going to be negative. 3 cubed is 27. Actually, one of the 3's cancel out, so it's going to be 3 times 3, so it's going to be just negative 9. All right, and plug in 3 here, so it's going to be plus. All right, so 3 squared times 3, so it's going to be 27 over 2. All right, minus, right, then plug in the lower limit, so it's going to be 0, right, plus 0 anyway, right? Right, since 9 is same thing as, let's say negative 9 is same thing as negative 18 over 2, so this is going to come out to be, right, 27 minus 18 would be 9 over 2, right? So this is the area of the enclosed region. All right, that's it. I hope that this was clear.